Thermoelectric coolers for projection lasers. Laser projectors for cinemas and large-scale outdoor venues, such as stadiums and concerts, generate 4K resolution images with a robust color palette up to 75,000 lumens. While commercial laser projector systems have become more energy efficient, these high-power laser systems still require up to 6 kilowatts to generate bright and crisp high-quality images. Heat generated by the laser can cause significant damage to sensitive laser components, including the laser module, optical scanning system, and laser diode driver electronics. To ensure proper functionality and maximum performance, temperature stabilization is critical. Depending on the type of laser projector, temperature control can be maintained by a recirculating chiller or an ambient liquid cooling system with a thermoelectric cooler. Laser diode technology has become standard for laser projectors due to its high reliability and long life operation. Laser light is generated by applying electrical current to a laser diode, which is then passed through a laser crystal. Compared to traditional lamp projectors, laser projectors provide a wider color range, brighter and sharper images, and have the ability to project at farther distances. The startup of laser projectors is also virtually instant, with constant brightness maintained over the projector's working life. In addition, laser projectors have a longer life expectancy with replacements after 20,000 hours, which is more than twice the lifetime of projection lamps. Designers are tasked with integrating a proper thermal management solution that meets the required heat pumping capacity of laser projector systems. Manufacturers of laser projectors continue to use higher-powered laser systems to enhance illumination and color, which results in higher thermal noise. Combine this with the trend toward miniaturization of laser projection systems for improved portability and simplified installation, and thermal management becomes even more challenging. Tighter space constraints also affect airflow, which negatively impacts heat exchanger performance. As the temperature of optoelectronic components drops below dew point, moisture will form on cold surfaces and potentially seep into the electronics, causing system failure. It is therefore important to protect electronics against condensation. Because epoxy or RTV sealant of thermoelectric coolers is not sufficient enough insulation, it is recommended to have a secondary insulation barrier to protect the thermoelectric cooler cavity. To maximize thermal conductivity in this application, a thermal interface material on either side of the thermoelectric cooler should be used during assembly. However, standard thermal interface materials, such as greases, can outgas and contaminate the lens. It is therefore recommended to use special thermal epoxies and phase change materials with low outgassing characteristics that have been baked in an oven to make sure all outgassing has been released prior to installation. Another option is to specify thermoelectric coolers with metallized exteriors and a low-temperature solder. Two methods commonly used to cool laser projectors are compressor-based refrigeration systems and ambient liquid loop systems that utilize thermoelectric coolers. Unlike liquid-to-air heat exchangers, both these systems have the ability to cool well below ambient temperatures. Compressor-based refrigeration systems like chillers deliver a higher coefficient of performance. However, this type of closed-loop system design loses thermal control as the fluid comes closer to the heat source. On the other hand, ambient liquid systems that incorporate thermoelectric coolers in the cooling loop enable spot cooling of the laser for more precise temperature control. Market leaders also tend to choose this solution because it is more cost-effective, reliable, and less complex. With no moving parts, solid-state thermoelectric coolers significantly reduce maintenance, operation, and total cost of ownership for laser projection systems. In this laser projector, a thermoelectric cooler is mounted between a cold plate and a cold block. Placed around the perimeter of the thermoelectric cooler is an insulation gasket. While the cold block is attached to the laser in the projector, the hot side of the thermoelectric cooler is attached to a cold plate that circulates coolant back to a liquid heat exchanger. One or multiple thermoelectric coolers wired in an array can be used to pump heat. For multiple arrays, thermoelectric coolers need to have lapped surfaces, so the thicknesses are within tight tolerances during mounting to the heat exchanger. This assures a minimal air gap between the thermoelectric cooler and the heat exchanger. Assembled with advanced thermoelectric materials, the new Ultratech series from Laird Thermal Systems delivers a cooling capacity of up to 296 watts. This new generation of thermoelectric cooler features an improved thermal insulating barrier, achieving a temperature differential of up to 72 degrees C. This series is ideal for demanding spot cooling applications that require high heat pumping in a small area, such as laser projectors. Compared to conventional compressor-based technologies, thermoelectric coolers offer silent solid-state operation, reducing maintenance and the total cost of ownership. The Ultratech UTX series is offered in 13 models covering various footprints, capacities, configurations, and voltage inputs. Temperature stabilization is critical for high-power laser projectors used in cinemas and light shows where heat must be quickly dissipated. While power densities continue to increase to improve image quality, designers are tasked with size constraints, condensation, and lack of airflow in laser projection systems. Not only can chillers provide a solution for many projectors, but ambient liquid systems with thermoelectric devices also offer simplified spot cooling to provide superior temperature stabilization that maintains peak performance of lasers. Laird Thermal Systems' Ultratech UTX series is a new generation thermoelectric cooler ideal for high heat pumping applications, such as laser projectors. The robust module construction features a higher thermal insulating barrier and delivers a 10% boost in cooling capacity compared to standard thermoelectric coolers. To find the optimum Ultratech UTX thermoelectric cooler based on your requirements, or to read our application note on thermoelectric cooling for laser projection, visit lairdthermal.com. Laird Thermal Systems develops thermal management solutions for demanding applications within medical, analytical, industrial, transportation, and telecom markets. If you have questions or need more information, please chat with us via the website at lairdthermal.com.